Alright, in this lesson we will talk about scalars and vectors. These are the learning outcomes of this lesson, and after this video I am sure that you will be able to distinguish between scalar and vector quantities and give examples of each. You will be able to add and subtract coplanar vectors, and you will be able to represent a vector as two perpendicular components. So let's get started. So basically we learned that physical quantities were of two types, right? Base quantities and derived quantities. Well, they are again of two types. One is scalar quantities and the other is vector quantities. So basically scalar quantities are quantities that have a magnitude, and vector quantities are quantities that have a magnitude plus it has a direction. So what do I mean by that? Well, first I recommend you to write everything on the screen and then I can get started. Alright, so basically let's talk about these two. One is speed, one is velocity. Very confusing, right? What is the difference between them? Well, let's think that I have a car here. Okay, a nice car. I have a car and I say that this car is going at a speed of 60 kilometer per hour, for example. 60 kilometer per hour. Okay, that's speed. It has a magnitude. It does have a magnitude, right? Yes, it has a magnitude. And what if I say that this car has a velocity of 60 kilometer per hour, wait for it, to the right. So this has a magnitude and a direction, right? This value lacked a direction. It just said that the car is going at 60 km per hour, meaning that it had a magnitude only. But when we are talking about velocity, it has a magnitude and it tells us about a direction, right? It's going to the right. Okay, let's see a much more practical example or something that you will frequently see in your exam papers, both in physics and as well as maths mechanics. Suppose I have a straight path, okay, and I say that this is the positive direction. This is the direction, right direction, positive. Okay, and I have a cute friend again. Okay, so this cute friend of mine goes this direction at a velocity of, suppose, 1 kilometer per hour, or let me just write something else, for example 100 meter per second, which is not possible, so 10 meter per second. 10 meter per second. Okay, so when I'm saying that my friend is going at a velocity of 10 meter per second, what do I mean? I do not have a direction here, right? But yes, I do, because I know that this direction is positive. So when my friend is going this way, in this direction at 10 meter per second, I say that his velocity is 10 meter per second. But what about his speed? His speed is also 10 meter per second, right? Well, now if I say that my friend goes this direction and he goes in this direction at 10 meter per second. So this 10 meter per second is his speed, right? What about his velocity? I cannot say that he is going 10 meter per second in this way. It doesn't make sense. So remember that I had given an initial direction of the field, right? That this direction is positive. So if he is moving from left to right, we consider it as a positive direction. So here, when he is moving from right to left, I can say that his speed is 10 meter per second, but his velocity is minus 10 meter per second. What do I mean by minus 10 meter per second? Well, if this direction left to right is positive, then definitely right to left is negative, right? If I say right to left, it should be negative. So if my friend is moving from right to left and we were saying that the direction from left to right is positive, then his speed is 10 meter per second, which is similar to this one, but his velocity is negative 10 meter per second. So here I can just add that I can add that his speed is 10 meter per second and his velocity is suppose plus 10 meter per second because it's in a positive direction. Alright, let's see another example. Let's remove the velocity and we will keep this direction. We will use it, and suppose that this friend of mine again, he traveled in this direction and he traveled a total of 10 meters. Let's say 10 meters, right? So his distance travel, we know that distance is a scalar quantity and displacement is a vector quantity, right? Okay, so his distance traveled is 10 meter. And what is his displacement then? I'll say we will denote displacement by d. His displacement is positive 10 meter, right? Okay, so if I say that my friend actually from here, my friend moved this direction and he moved 10 meters again. Okay, so we know that his distance is again 10 meter, but his displacement will be minus 10 meter, right? Alright, pretty simple. But what about I say that I want to find another displacement? Let me just rub all of this right now. All of this, all of this. Okay, so what if I say that my friend first came here and then my friend again came here and I want to know his displacement. So right now, how much distance did he travel from point A to point B? Remember that from point A to B he first went to C and then from C he came back to B. So if I am to calculate the distance travel of my friend, first I have to find the distance between A and C, right? And then I'll find the distance between C to B, which is practically the same distance. So I will say that my friend's distance traveled is A plus C. Wait, let's say A to C plus C to B, right? But what about his displacement? If I were to measure the total displacement, and remember that displacement is a vector quantity, it has a velocity, it has a magnitude and it has a direction. So if I say that my friend traveled from A to B and its displacement, then let's see. His first displacement was from A to C, so we will write AC, and we do know that AC and CB are similar, right? So just ignore that. So it's AC, and then he moved from C to B. So C to B. However, we will add this, but the direction from C to B is negative because left to right is positive and C to B is right to left. So basically it's like this direction, which we know is negative. So we will put a minus here. And we know that AC and CB, the distance is same, right? So we can say that CB equals to AC. So it's AC minus CB. So, well, it means AC equals to 0. What do I mean by that again? We know that the distance between AC and CB is same, right? Because A and B are practically the same point. So we can say that the distance of AC is equal to CB. However, the direction is different. So we can say that AC plus minus CB, or we can say if we replace CB with AC, AC minus AC equals to 0. So for example, you are standing at this point and you go this path, this path, this path, this path, and you again came back here, your displacement will be 0. However, your distance will be this whole distance that you travel from here to here to here to here to here to here. I hope you understand. Now let's go to a little bit difficult topic, not very difficult. I am sure that you have studied in O level. Let's go adding coplanar vector. First of all, we'll see the tail-tail arrangement or parallelogram rule. What do I mean by tail-tail arrangement? For example, I have two vectors. I have a vector P and a vector Q, and both of them touching their tails. See, this is the tail, and let's assume that this is the tip. So this one's tail is this one, and P's tail is this one. So they both touch at their tail. So how to solve a vector like this? Well, basically we will follow the parallelogram rule, which is pretty easy. So what we are gonna do here is that we are gonna draw a parallelogram. Let's draw a parallelogram. All right. Okay, let's just assume that it's a parallelogram. Okay. Yeah, and we will copy this too. Okay. Okay, just let's assume that these are connected and there is no extra, right? Or let me just remove it a little bit so that it doesn't look that odd. Yeah, done. So basically when we have drawn something like that, to find the addition of P and Q, what we are going to do is that we will simply draw a line from here to here, and let's rename this line to R. So basically the addition of P and Q is R. Well, let's see something. We constructed a parallelogram, right? So if we know this this vector, the length of this vector and the length of this vector, and we know this angle, we can easily build up a parallelogram, right? Alright, so this is how you find the addition of two vectors if they are in a tail-tail arrangement. Let's see another arrangement, that is tail-tip arrangement. So basically here we can see that we have two vectors, right? So one has its tail here and its tip here. For example, for the vector P, this is the tip, but for vector Q, this is the tail. So it's a tail tip arrangement, and if we are adding two vectors which are in a tail tip arrangement, what do we need to do? Well, this is pretty simple. All we need to do is draw a vector from this tail to this tip, and well, let me draw a straight line so that it's nicer. So we will draw a straight line, and that's it. We have a tail tip arrangement, and we can say that this vector that we just drew from the tail of P to the tip of Q. Let's see, P had its tip here, right? So the tail of P to the tip of Q. This vector R is the addition of P and Q. Let's see another example. This one, for example. Here we can see that the tip of P is connected to the tail of Q. So drawing a line from the tail of P to the tip of Q will give us the resultant vector of the addition of P and Q. So this is the addition vector. Let's say another example. Suppose we have this tip, tail, and then again tip of this, tip of Q and tail of S. How do we do something like that? It's pretty simple. If we see that a vector is something like that, where it's like tip, tail, again tip, tail, then we can say that the resultant vector is a vector from the tail of P to the tip of S. So this is the resultant vector. Alright, let's say another vector, and this is a little bit important and you need to understand it. So we have a vector P and Q. So P is the, here we can see that the tip of P is the tail of Q, right? So a vector should be drawn from P to Q. However, see that I have already drawn it, but I have given it a negative direction. So what do I mean by negative direction? Well, if this vector is R, then I can say that a vector drawn in this direction will be minus R, right? Because you know these are of the same length and the only difference is the direction. So if this direction is R, then if this direction is R, or if this direction is positive, then definitely this direction will be negative, right? If this direction is positive, then this direction will be negative. So I can say that P plus Q equals to minus R, right? Minus R. And I can also say that P plus Q plus R equals to 0. As simple as that. So remember, if we have a vector, let me just remove it so that you can understand better. If we have a vector that's taking a round like this, right? It's taking a round like this way. It's moving in a specific direction. In such cases, we can say that the addition of all these vectors result in a 0. Let's see subtracting vectors now. Well, subtracting vector is like a myth. Okay, we will use the addition rules to subtract vectors. Let's see how. For example, we have a vector like this, right? So this is Q and this is P. But I want P minus Q. So just something I discussed before. If this direction is positive, then definitely this direction is negative, right? So if this is Q, let me just copy this. Okay, so this direction if this direction is positive, then this direction is negative. And if I remove this, okay, so I can say that if I change the direction, the value is same, right? I'm not increasing the length of it or decreasing the length, so the magnitude is same, but the thing I change is direction. Now at first it was in this direction, but now I'm changing the direction to this, so I can say that this is minus Q, right? This is minus Q. So now we can name this vector minus Q, and you can see that this is a tail tip arrangement, right? The tip of minus Q is touching this one, and the tail of P is touching the tip of Q. So I can write that P minus Q, not minus, let's write like this, P plus, so we know that the addition of this vector and this vector is a vector from here to here, right? So let's add P plus, we are adding minus Q, right? Minus Q equals to R. So we can say that P minus Q equals to R. As simple as that. Let's see another example. So here it's pretty much the same. However, we can do this in parallelogram method too, but I don't recommend parallelogram method because basically you can do all the calculations in this triangle method and it's pretty easy. So I'll recommend you to follow this one. Alright, now we know how to subtract the vectors. You can just manipulate the values and just make sure that they come into any of this arrangement and we can just make the calculations, right? Okay, so let's see the next topic, that is representing vectors as two perpendicular components. Alright, so you need to focus on this one because probably you did not learn this in O level and you will need this in mechanics 1 too, so pretty important topic. So basically suppose that I have a force in this direction. I have this point and at this point I am putting a force in this direction. So basically this force, let's rename it to F. Okay, so basically F is suppose 10 newtons. F is, oh no, let's write a one value. F is 5 newton. And suppose that this is Y and this is the x-axis and the force is in this direction. And suppose this is 30 degree. This is 30 degree. So basically we can say that this force F has two components. It has a vertical component, and it has a horizontal component. So what do I mean by that? By component I mean that this force F is made of two forces acting on this point, and this F is the resultant force of the two force. One is the vertical force, one is the horizontal force, and when these two forces acted on this point, the resultant force is this. Remember that while we were talking about vectors here, adding vectors, we said that force here and force here and the resultant force was this one. It's the same here because we know that force is a vector quantity, right? So a force in this direction and a force in this direction, think of it as a vector in this direction and a vector in this direction, and the resultant vector or the addition of these two vector gives us a vector in this direction. So how do we find this? If we want to find this, suppose the vertical force or the horizontal force, well, it's pretty easy. For the vertical force, suppose the vertical force, we can say that the vertical force is F sine 30 degree. If this is the degree, I'll talk to you about why it's sine 30 degree as well. Just bear with me now. So it's sine 30 degree. So we know that the force in this direction is F sine 30 degree. Sine 30 degree. And we have a force in this direction, right? The horizontal force. So we can say that the horizontal force is equals to F cos 30 degree. Now why am I saying that it's sine 30 and cos 30, right? Well, let's look. Let me draw a graph for better understanding. Suppose I have this graph and this is the force, right? Now I do know that there is an angle 30°, and I want to find this force and this force. So let's complete it as a triangle first. Let's just convert it into a triangle, suppose. So we want to find the vertical force, this one, and the horizontal force, right? So basically the horizontal force we are talking about is this, right? This distance, or the magnitude is this one, and the magnitude of the vertical force that was applied is basically this one, right? So if we want to find the vertical force, for example, what we are gonna write, suppose that we know that this is 5 and we want to find the height of this triangle, which can be also said as a vertical force. So to find it, we write height equals to 5 sine 30, right? It's typical trigonometry, right? And to find out this distance or this magnitude, we use cos, right? We can say if this is, for example, h, let's write h. So let's just write it as vertical v, because otherwise you're gonna be confused about height and vertical force. So it's horizontal force, right? And to find this distance here, we use 5 cos 30, right? Still confused? Okay, so basically we learned trigonometry, right? That sine 30 equals to opposite by hypotenuse. So sine 30 equals to opposite, which is height, by hypotenuse, which is 5, right? So h equals to 5 sine 30. This multiplies here, right? As simple as that. Let's practice some force distribution, right? Because representing vector or vector components as two perpendicular components, it's a little bit confusing sometimes. So let's do some practice. Suppose I have this, and this is a graph, and I'm drawing a force here. All right, not a straight line. I'm drawing a line here, and I said that this force here is 10 Newton, and I said that this angle here is 30°. Okay, and I ask you to find the vertical force, the vertical component of 10 Newton, the vertical component. So basically you need this one, right? So let's just draw a line here, and if we draw a line here, you know that, let me just write this 10 Newton somewhere else, or you get confused for sure. So let's write this as F, and let's write here that F equals to 10 Newton, and we need to find the vertical component of F. Find the vertical component of F. Okay, so how to find the vertical component of F? So we just drew a straight line here. I know that this is F, and I need this one, right? So which formula do we use of trigonometry to find? We use the cos formula, right? We can write that cos 30° equals to, we know that cos is adjacent by hypotenuse, right? So this is the adjacent side, and so it's, let's write that we are finding the adjacent side, right? We are finding this side, so it's v by hypotenuse, and the hypotenuse we know it's 10. So basically v equals to 10 cos 30, as simple as that. So basically this is the vertical component of F. To find the horizontal component, the procedure is exactly the same. We need to find this one. Right now you might say that the force is in this direction, the force is in this direction, so it will have a component in this direction and this direction, right? So why am I finding this one? A lot of you might have this question. So basically why I'm finding this one is that you see we are asked to find the magnitude, right? And you see this force here, the distance or the magnitude of this force and the one we draw here is same, because you see that this distance, or let me use a different color, I think that will be better. Suppose this distance here is actually equal to this distance here, right? It's the same distance. So basically it's the same. If you find, suppose I'm completing this triangle, and let me just use a different color, blue for example, and if I complete this triangle, I can say that this distance is equal to this distance, or this magnitude, that's the correct term, this magnitude is equals to this magnitude. Alright, pretty simple. Now let's see another example. Okay, I'll just remove all this and we will see another example which will be a little bit challenging, I think, but not so challenging. These are pretty simple stuff. You're just new to this and it might look hard, but as long as you start practicing, even in M1 as you start practicing, you just get used to it. So not this graph for sure. I want a graph like this. No. Alright, I want a graph like this, and I have a force. Now let's work on a simple one. Yeah, I have this one, and this is a graph. Not really, I need something else. Let's see what I can get. Alright, this one. Yes. So I have this graph, and I tell you that I have a force here. Suppose, let me draw a straight line. I have a force here, and well, labeling, I'm saying this, that this direction is y, this direction is x, this direction is negative x definitely, and this is y, and this one here is 0. Let's say that this point here is 0. So if I tell you that this angle here is suppose 10 degree, what are you gonna do? So it's pretty simple here, but you need to understand that this force F that we drew, let's name it, this force F is a vector quantity, so it has a direction, right? Previously when we are working, all the options here were like in the positive direction. This was the positive x, this was the positive y, but here we have one item that's in the positive x, right, and it's in the negative y. So let's think of the components. This is the force, so it will have a component, let me use a different color, so it will have something in this direction and in this direction, right? Because these two force will make this force. Okay, so this force and this force is the addition, like F is the resultant of this and this force. Let's name this X force. Okay, X force, and then let's name this Y force, as simple as that. So now if I say this is 10 degree and I need to find x and y, x force and y force, what do I do? So basically the x force is pretty simple. I need this distance and I can just draw a line here and make it a triangle, and then we use the cos formula, right? We can say that x, oh let's write the value of f equals to uh, 5 Newton. So we can say that x equals to 5 cos 10 degree. It's pretty simple. 5 cos 10 degree, right? And we can just find it, the x force. But what about the y force? When we're talking about the y force, you see, because this is in the negative y-axis, right? And we are asked to find the force F. So suppose we are asked to find, let me write it, find YF and its direction. So if we are given a question where we are saying that we need to find YF and its direction, first let's just find the magnitude, right? That's the easiest one. We have drawn a triangle here, and we know that this F is 5 Newton, and we need to just find this distance, right? This distance. So we can write that Y, let me just write, yeah, YF equals to, so we need to find this. We will be using the formula. Which formula? We will be using the sine theta, right? So we can write that 5 sine theta, theta is 10 degree here. Okay, so the value will be 5 sine 10 degree. Now what about direction? So we know that this is the positive y, right? And this direction is definitely the negative. If the upper direction is positive, then the down direction is negative, so the force is downwards. So we can write that 5 sine 10, whatever the value is, I definitely not know the value right now. We can say that 5 sine 10 degree, the force YF is 5 sine 10 degree. Either you can say downwards, or you can say 5 sine 10 degree negative. The choice is yours. You can either say 5 sine 10 degree downwards because it's going downwards, right? And otherwise you can say negative 5 sine 10 degree. Given that the upper part is positive, it means that negative means down. As simple as that. So basically you might be a little bit confused based on these things, because I know that the components are a little bit confusing as you're just in AS level, but I don't think that they will be too much complicated as soon as you practice a lot, because basically it requires practicing, and at a point it will be like you won't even think much while doing these calculations. So the key to understand the vector components are to practice a lot so that you are familiar with them. I'll suggest you to complete the quiz that we have after the summary, and then we can get started. Alright, so I think that's the end of this lesson. Let's see if we understand the learning outcomes. So first one, distinguish between scalar and vector quantities. We know that, right? We know that scalar and vector quantities are basically quantities. This, like scalar has a magnitude only and vector has a magnitude and a direction. We know that. And then we have add and subtract coplanar vectors that we did. And at last we represented a vector as two perpendicular components. Alright, I think that's the end of this lecture and the end of this topic, but we will have a summary, and we will like get back to the summary and see that if we have learned and if we have completed all the learning outcomes. Thank you.